All right. Okay, thank you. Okay, so how you guys been doing? So I think this is already your fifth week, right? So and it's gonna be the last week for you guys before you guys gonna have a midterm break. And for Malay student, they're going to celebrate Hari Raya. So I think I mean you guys are starting to get busy, and there's gonna be a lot of assignment, tests, you know. So hopefully you guys can manage it well before the break, right? Okay, so a bit recap on what we have been doing for the past 4 weeks. So we already covered a lot of fundamental things that we're going to have in the in the computer. Right. So basically, what we are learning in this class or in this subject, POCA, Principles of Computer Architecture. So we are learning about the structure of the computer. So we are learning all the things separately. So just to get understanding step by step before I think the ultimate thing is for today's lab. So we're going to discuss on how the example or the emulation of a complete processor, starting from the memory we are giving the instruction until we get the output. All right. So I think before I'll pick a name, just to want to see you guys. I mean, how you guys been doing? The exercise that have been given to you guys. So do you guys have any question? All right. So if you guys have no question, then let's go and I just pick a name. Then I'm gonna go. You guys gonna need to share your screen and show me what you guys been doing. Okay. All right. Yinchu. Okay. So yeah, time scale is just a reference point for the programmer, telling that at what time scale that your design need to work, right? So it has no direct effect to the code, right? Even if you want to remove it, it should be okay. All right. Okay. So then any other question before I pick a name? All right. Okay. So all right. So let's start with Chun Kit.
Okay. Good. So, can you see the output waveform?
Yes, can see. Yeah.
So it is, so it does work.
All right.
Replicating the same output from the lab video.
Okay. Okay, wait. This is not your output, right?
Oh,
So
I haven't shared it. Okay.
yeah.
Wait. There we go. I think this one.
Nope. So this is your input, right?
God damn it.
You have to show the output after the simulation.
Yeah, this one.
Yeah, all right. You want to explain a bit about your result?
Uh, so it just runs exactly the same as the code supposed to.
Okay.
So I just choose the same input that the lab video has been given.
Okay.
So let's apply it, and it's same as
Right.
the
Yeah. Do you understand? It's actually what you are doing.
yeah.
All right. Okay. All right. So thanks, Junkit. So let's go to another student. Lucky one this morning. Uh, Chung Jin.
Hello, sir.
Yeah. Hello. Go ahead. Share your screen, Chung Jin.
So, sir, this is my output for the control unit.
Okay.
So, regarding to the code, for the 000 bit, my register destination will be 0 bit and ALU SRC will be 1 bit. So, 000, my ALU SRC will be 1 and the destination will be 0 bit.
All right.
So follow back to the 001. Registered destination is 0 and the ALU SRC is 1. So 001, the ALU SRC is 1 and the registered destination is 0.
Okay.
So continue with the second lab or
All right. Yeah. Go ahead.
so this is the register. So the output waveform is like this.
Okay. Wow. There's a lot.
The my right data is my matrix number, which
Okay.
20167. So
Okay.
the register output for the one data and the two data will be same with the every positive
Wow.
out.
Yeah.
So
Okay.
the third one is the ALU control, which the 10 and the XXX I put 10 and the XXX out output I put 111, then the output will be 000.
Okay.
So second line will be 01, then XXX, the output will be 001, then the third one will be 01, then output 111, then the output will be 001.
Okay.
That's all for me, sir.
All right. It's good. Thanks, Chung Jin.
Thank you.
Yeah. How to pronounce your name? Chung or Chong? How you
Uh,
pronounce it?
Chong Xian.
Chung Jin, right?
Yeah.
Okay. All right. Okay. Then who else? Muhammad Afiki.
Hello, sir.
Afiki. Go ahead.
Okay, sir.
Puasa tak Afiki?
Oh, sir.
Alhamdulillah.
So,
Go ahead.
kalau for the control unit, this run simulation
Okay.
for the outcode 000, we get send data for register DST 0 for LUSRC 1 all this one all get same
All
for
right.
0 and 01 still same all the way to 1010.
Okay, next lab.
Select. Okay. Then need to open another project.
Alright, go ahead.
Okay, sir.
Okay, alright, go ahead.
For the register, my metric number start from 21091, and you will write data my 21091 into destination register 000, and then you will read register 000 same as my metric number 21091, and increment by 1, put at register 1, and when reading at register 1, you will show the same output when you write the data,
Alright.
and so on.
Okay, alright. Okay, thank you, Vicky.
Thank you, sir.
Alright. Okay, Vicky. Nabil, last time did you present, Nabil?
Yes, sir. I have present.
Already, eh? Okay, okay,
Yes.
alright. Okay. Thank you, Nabil. Ethan already, right? Ethan already present, Ethan?
Belum.
Oh, belum. Okay, go ahead. Present, Ethan.
Which lab?
I think 2 of the lab it should be okay. The register one and also the what do you call the ALU control.
ALU control is lab 3 kan?
Sorry, the ALU what do you call it? Oh, ALU control is lab 3 ah. Then just do the register lah.
Boleh tengok. Ini lab 1.
Alright, go ahead. Yeah, present.
So this one normal, this one based on this bit, then ini akan 0, 1, 1, 1, 1, then over here. This one first bit, then register distribution 0, over here 0, and then this one ALU source. Just follow this
Alright,
one.
alright. Okay, alright. Do you have
And then,
any
second
problem
lab.
doing? Okay. Alright. Any problem faced?
Oh no, this one okay. This time okay.
Alright. Okay. Go ahead. Continue.
Lab 2 saya kena open new project.
Oh.
So this one ada follow up last 5 digits.
Wow. Okay. That's cool. Okay. Go ahead.
And then so kena so ini pun ada change lah from 15 to 19,
Okay.
and
That's
then this one from 16 to 20.
all right.
Then dia input di sini, dia output di sini.
Okay. All right. So I think you understand it. That's good, Ethan. Right. Thank you.
Yeah, okay.
Right, guys. So the measure of how well you understand the code is when you are able to do some modification. So I mean I like to see that kind of confidence. So that's good for you.
Okay. Thanks.
All right. Okay. Thanks, Ethan. So let's go to Shenwen. Shenwen or Shenwen?
Xianwen.
Shenwen. All right. Go ahead. Share your screen, Shenwen.
Okay. Okay, so this is my register code, and now I want to show the waveform. So this
Okay.
is the register one. So when I input for the first register here,
Uh-huh.
this is my metric number 2124.
Okay.
Then my first register data out will have my metric number.
All right.
And then for my second, the next sequence of my metric number is 21125. After this input, I will get 21125.
Okay. All right. Okay. All right. Yeah. Thank you, Shenwen.
Need
So
to
I
proceed
think
to another project.
it's okay.
Oh, okay. Thank you, sir.
Okay. Guys, the other thing that I think is important for you guys is the presentation skill. So yeah, Shenwen, I think you did good. So same goes as all of you. So you have to practice on that, so that because later when you go into the industry, right? So being an engineer is not just about your technical skills. So you can be genius, you can be very smart, but if you don't know how to communicate, then I mean it's hard for you to grow, right? So I think that's why in the lab, I mean I'm asking you guys to do some presentation, because I just want to first I want to make sure that you guys are doing your lab, and then the second one, I just want to see your presentation skills. So when I mean the if you do it more time, then you're going to sharpen your presentation skill, which is going to be good for you guys later when you go into the industry. All right, thank you, Shenwan. All right, so Nick already present. Nor Afifa,
Yes, sir.
go ahead, share screen.
Can you see my screen?
It's coming. Okay, yeah, I can see it right now. Yeah.
Lab. Which lab, sir?
Which lab you want to present first? It's up to you.
Okay.
But don't present the Netflix one, right?
Alright. Okay, first one is ALU control. So
Okay.
this is my coding, and this is the output. As you can see, ALU operation here is 00, and opcode is 000, and you can see in coding 00. 00000 is default, so the output will be 000.
Uh-huh.
And then LLU operation 01 and opcode 0001. You can see here 01 and XXX in the back is any value. So the output will be 001. And same goes to other output. You just follow this coding.
That's good. Next lab.
Okay. Next is control unit. Okay, control unit. It also depends on the opcode. If the opcode is 000, then the output will be as set in here.
Alright. Afifah, go to the register. Explain the register.
Okay.
Oh, your background is keep on changing. You have many windows or
This one is register. So
Uh-huh.
I have changed the coding to 90, 19,
Okay,
and
that's
20.
Mhm.
Okay, so my matching number is 21127. So I already set here in write data, and I enable for register 1 and register 2. So they only read these two number,
Uh-huh.
and here is the output in address 1 and address 2. My matching number.
Alright, okay. Thank you, Afifah.
Okay. Okay, thank you, sir.
Alright, so let's go to Nur Hafiza.
Yes, sir.
Yeah, go ahead, Hafiza. Share screen.
Can you see my screen, sir?
It's coming. Alright, can see it now.
Okay, first part is LU control.
Okay.
So this is the output. When a LU operation 00 output 000, so the output is 00. The output is based on the code, so it follow the default, so the output is 00.
Okay.
And then next is LU operation 01 output 001, so the output is 001.
Alright. Okay, that's good.
Because
Hafiza. Go to next lab. Go to register one.
for control
No,
register,
just keep it to register. Yeah.
okay. I change my coding
Okay.
to 0 to 19,
Okay.
and then the output is
Why? Why do you need to change it to 0 to 19?
because the question asked to change the width to 20 bits.
Okay. Alright.
Okay. So my metric number is 21137. So it's still at location 0. So the output is 21137 and 21137.
Okay.
And for next one is 21138. So for register data 1, the output 21138. But for data 2 is 0 because uh, value for location 2 is not stored yet.
Alright. Okay. Alright. Thank you, Hafiza. So let's go to Nur Ifa.
Hello, sir. Can you hear me?
Yes, can hear you, Ifa.
Okay. Okay. This is my register coding. I changed it to 19. And then this is the output. So it count increment by 1.
Okay.
Number matrix. It's increment by 1, sir.
What's that? Go ahead, present, Ifa.
This is for my ALU.
Okay.
And then okay, this is the output for ALU.
Alright.
Okay, that's all, sir. Okay, thank you, sir.
Alright. Okay, thank you, Nur Ifa. Okay, let's go to Nur Laili.
Yes, yes. Okay.
Can you see my screen?
Yep, you can see your screen.
Okay, first, so for ALU. Okay, so this is my building and this is my waveform. So as the code said, when we input 10 and the others don't care, or one, the output will be 000, right?
Okay.
So 10, the output will be 000. Okay, yeah. And then when 01 and don't care, so the output will be 001. So yeah, we got 0012 and status. Okay, so
Okay, go ahead. Next lab. Really.
okay, right. So for the lab for register, we need to change for 20 bits, right? So I changed here, but I forgot to change over here. But the waveform still got the answer.
Okay.
Okay, so when we when my metric number is 21144, so when I input it over here, the output when I read 0, the output will be 211442, but after the positive H drop.
Why?
Because at the coding, it says here that it will start fitting the right data into the right destination only when positive H clock. So it starts to kick in the data after the positive H clock. So it can only read after the positive H clock.
Okay.
So after that, for this second one, when I ask for it to read, there's no more zero in front because the data already inside the system.
Okay.
That's what I was.
All right. Thank you, Laili.
Okay.
That's Nur Suhaili.
Yes, sir.
Okay.
Can you see my screen, sir?
It's coming. All right. Can see it. Yep. Go ahead.
So for this for ALU, so regarding to this coding, it show that when ALUOP is 01 and opcode is XXX, the output will be
01 or 10. That one.
10.
Okay.
Sorry, 10, and the output is XXX, and ALU control will be 000.
Okay.
This one.
What does the
And
XX mean, Swahili?
yes,
What does the XX mean?
any number.
Alright, don't care.
I don't care.
Okay, go ahead.
We'll continue to another lab, sir.
Yeah, next step.
For register. Wait. Okay, for register, I already changed this to 0 to 19 and 20 for register array. My metric number start with 21145. So I already set at register 0. Oh, wait, it's not output. Oh, this one. So the data will appear 21145 at positive edge.
Okay. Why there's a 0 there between 21145 and 21146?
Because metric number will appear at positive edge.
Okay.
For ALU control.
No, wait, sorry. Why there's a 0 in between there?
Because in coding, they say always positive edge.
Okay.
The output.
Alright.
So it will appear at positive edge, my metric number.
Yeah, then where does the 0 comes from? Sorry.
Yeah.
Where does the 0 comes from?
Register address.
No. Between 21145 and 21146, right? There's a 0 at the output, right? So the output must be taken from somewhere, right? At the location. So where does the 0 comes from?
Register right destination. Is it true, sir?
No. So register right destination is your address. Right, so that's your address. It's not the content. Itu alamat rumah, right? It's not what is inside the house. So what you are showing in the output is what is inside the house, the content of the house.
From register address 1.
Sorry?
From register address 1.
Okay. All right. So why there's a 0? Because the default value, right? So right now, I mean, if you look on, when you try to read, right? So you read address 1. So what does that mean? You are trying to read from register 1. Right, and then location number 1. So same goes at the read address 2. So you are also going to take from the location 1. So what happened at the location 1, before you are writing your metric numbers 21146, right?
Yes.
So which happened at the positive edge of the clock. So before that, if you see there's a gap, right? Between the clock. Yeah, so that's why the location is initially 0. Okay, so it's already starting to read from the location of your register. But at that time, the value inside your register is 0. So that's why you got 0 there in between. Oh tu faham ke? Sorry.
Ya.
Huh?
Faham.
So after the positive edge, then you started to write in it. So that's why you can see after the positive edge of the clock, then you see the value. So it's repeated, right, again and again.
Okay, sir.
To make sure faham, right? So because later in your lab, we're gonna have lab tests. So it's really gonna test your fundamental knowledge in this lab. Right. Thank you, Saidi.
Thank you, sir.
Okay, let's go to Nurul Hanna.
Yes, sir.
Okay, go ahead, Hannah.
Can you see my screen?
Yep, you can see it.
Oh, okay. This is my ALU control.
Uh-huh.
Okay. So in my ALU control, when it is 00, it will read the output ALU control here, which is 000.
Okay.
Okay, and if is 10, it will be XX, and it will read the ALU control 000 here. Same as 01. It will read 001 here. Okay. And I try to add 111, and it will go on default right here at the control.
Alright. Go ahead, next step.
Okay. Okay, my register. Here, so because of the instruction, need to change to 20 bit. So I change my register to 0 to 19. And here, my 0 is my first 5 plus digit of my trade number.
Okay, alright, Hannah, thank you.
Yes. Okay, sir.
Alright, so let's go to Nurul Nurul Izzah. Belum, okay, Nurul Izzah. Nurul Izzah.
Yes, sir.
You are not Nurul Izzah Anwar Ibrahim, right?
No,
Okay, okay. Right, go ahead, Izzah.
wait. Okay, this is for the ALU control.
Uh-huh.
This is the code and the wait, I found that. And this is the simulation.
Right. Show me the register part, Izzah.
Okay. This is the register part that I made.
Okay.
I changed the value. It's need the we to change to the 20 bit.
Okay.
This is my waveform.
Right.
It's only
change the
become
radix. Change the radix
okay,
for register.
because of the we only add the code, we change that we say that it only read when the positive edge. So this will become
wait. It's only read or write. Check the code. Iza.
Wait. It only it write.
Right. Yeah.
Yes.
During what?
Positive edge.
Okay.
Yes.
Go ahead. Show the waveform. Okay. Continue your explanation.
So it increment one by one. This is my metric number. 21154. So it increment one by one.
Okay. All right. Thank you, Iza.
Okay, thank you, sir.
Okay. So let's pick the last one.
So I have a question.
Go ahead, Jin.
Okay. Okay, so can you see my screen?
Yep, can see.
Hello, sir.
Yeah.
Can you hear me? Okay,
Yep.
sorry, lagging just now.
All
Okay,
right.
can you see my screen?
Yep, can see.
Okay. Now, I have changed the coding right now. I've changed to I make only one of the right data.
Okay.
Okay, so means that I only write one data inside for the coding, and then it will be automatically into the address one.
Okay. All right.
Okay. After that, I make it the data I write before plus one into the address two. Can
Okay.
Okay.
All right.
Okay. Can you see? Okay.
Yeah.
But
Yeah.
the result I got is my matrix number here. The first one is okay, but the add one supposed to be 21069, but only it cannot show.
You want to make it increment?
I want to make it increment as the set for the safe value before.
Okay. Let's look into your code.
Okay.
Okay. What's happening here is that all right. So if the register always at positive edge of the clock, begin. So it's going to check, right?
Yes.
So it's going to check whether the register write enable is high or low. So if it is high, then begin, right? So begin writing. So what happened is that because only if the register write enable is low, then it's going to do the else.
Yes, else here.
Yeah. So did you during the simulation did you set the register write enable to low?
Yes, I only set for high as the first value I write.
Okay.
And
All right.
after that is low.
So after that is low, and
Yes.
then when wait register right data plus one. Okay. Show me the waveform. So when the register enable is low, the output just remain, it doesn't change. Okay, let's look at the code again, Junior.
Okay. So is it the because of the write data I didn't save the value? Is it need any return form to save the value?
Wait, register write data. Register write data. Where's your register write data? You set it as what?
The register write data, the before one, that is my matrix number.
Okay.
That is my matrix number, and now I want to use it back to n+1 value on it.
Scroll up a bit. Your register write data. So your input. Yeah, you can try two things. So the first one, try to set your input as a register. You cannot. Wait. I think input cannot set as a register. So I think you just can set output as a register. So so there are two ways, you know. So the first way is that you can have another register to store your register write data, right?
Yes. How to write that?
Just declare register.
Declare and register.
Yeah, register, and then the size, the same way like you declare the register array.
Okay.
But you don't need this 0 to 7.
No need the 0 to 7.
Yeah.
In this form. No need this form.
Yeah, because the 0 to 7 is just a row, right? So we don't need the row. We just need the
such as I put the register to like this one.
Yeah.
Okay.
No. The register is fixed.
Register is fixed.
Yeah, it has to be REG, right? Because there's a syntax.
Okay.
All right. So the size, then you give the name.
Okay. The size.
Okay.
The size same as here.
Yeah.
And
okay.
then
I'm not sure this is gonna work or not. So you can try this way. So you can give whatever name, right?
Okay.
And then you assign the value. So you assign the value rec.
No need the 7. No need.
No.
Okay.
You don't need that one. Yeah.
Okay. And then else here we put the save at here, right?
No, you can do the assignment outside of the what do you call it? Outside of the always.
Outside of the always. Okay. So assign.
Assign.
Inside the register array.
Yep. Yeah.
AR2 equals to the register write data.
Yeah.
Outside the always, can it perform the inside the always one here, the else?
Yeah, sure. Because yeah, this is just a connection. It's like, you know, you are setting the connection of the wire.
Oh, okay.
Yeah, because
okay.
we are dealing with hardware, right?
Okay, then I try run first, and I will give you the
Yeah.
result later. Okay,
Yeah.
thank you, sir.
All right. So there's one option. The second option, use the for loop.
For loop, yes, I have tried also, but fear of that.
Okay, all right. So I think maybe we can discuss offline after this.
Okay.
Give a try first, right?
Okay, I give it a try first. Thank you, sir.
Okay, all right. Okay, so let's pick the last one for today's lab. Who's Nurul Izzah? After Nurul Izzah is Nurul Izzati.
Yes, sir.
Go ahead, Izzati.
So this one is for my ALU control.
Okay.
This one is my coding. And for the output is this one. So for ALUOP00 and opcode 0010, the output I will get 000, same as the coding in here.
Okay.
So for the register, this one is my coding for the register.
Right.
And for the output is this one. My metric number is 22733. So I put at location 1.
Okay.
And if I run, it will show up at here. And then the increment number is at here.
All right.
Okay.
Why there's a 0 in between there?
Because initial value must be the 0.
It's not must. Initial value is 0. That's what you said in your code.
Yes.
Right. Okay, thank you, Izzati.
Okay, sir. Thank you.
Okay guys, so let me share my screen right now. So I'm going to explain about lab 5, right? So this is the ultimate lab lah. So this is gonna be the like your base starting for your mini project, right? Okay, alright. So can you guys see my screen right now? Guys, can you see my screen?
Yes, sir.
Okay. Alright. Okay guys, so lab 5, right? So lab 5 is regarding the regarding the 16-bit RISC processor, right? So this is the emulation, right? So the emulation of a RISC processor. So what does the RISC mean? RISC means reduced instruction set computer. So a lot of architecture that you guys are using nowadays, so they are using RISC architecture. They have a simpler instruction sets, right? So I think it's easier to understand RISC processor. Right, so what we are doing today is we are combining, right? So the whole module, and of course there are additional modules, to perform a simple processor task, right? So that's why if you can see in the element here, right? So there is instruction memory and also there's a data memory, right? So we're going to start from the instruction, right? So from the instruction memory, then we're going to take the instruction and we're going to convert it into those signals, right? Then later we're going to perform some operation, right? So that's why if you look in the code given here, so there's an instruction set, right? So instruction set, this is exactly as what you have learned in your micro P assembly language, right? So in your micro P subject, so this is what happened in a computer, right? For an example, right? So in a computer, so let's say you let's say you open let's say you open your okay, let's say you open your PowerPoint, right? So we open PowerPoint. Okay, when you install your PowerPoint, so this is your computer, right? So this is your PC. So this is your PC, and here is the processor. Right, so here is your processor. And then it's connected to your main memory. So this is your main memory, MM. And then here is your hard disk. Your hard disk or your what they call it, SSD, solid state drive, right? So it's depend. So, okay, let's say you just bought a laptop, right? Then you want to install Microsoft Office. So you download it. So you download the software is going to be stored in hard disk. Then you start the installation process, right? So of course it's going to utilize the memory and processor. But after you install, so there's gonna be a part in your hard disk or in your SSD where you stored all the PowerPoint files, right? So if you look into your C folder, you can see, let's say Microsoft, and if you open the Microsoft folder, then you can see a PowerPoint folder. Okay, what does they have inside here? So it contains the instructions. Right, so they contain instructions inside here, inside your hard disk. All right, so that's why when you want to open your PowerPoint, right, it's going to take a while. Why? Because the processor need to go and fetch all the instructions from the hard disk. All right, so I've told you guys, so the designer, to optimize the performance, they try to reduce, any attempt to go and fetch something from the hard disk. But to open a new program, of course, you have no other options rather than you have to go into the hard disk and pick something, right? So that's why it's going to take a while. Of course, it's going to be a, time difference if you are if you're using SSD or HDD, hard disk drive, right? Right, so then it contains the instructions and also the data. Right, so when you click PowerPoint, it's going to go and fetch and start to transfer the data in the main memory. All right, so main memory is huge, right? So let's zoom the main memory. So they're going to do some division, right? So let's say address from, this is the example, right? So let's say address from 0 to 99. Oops. Store the instruction. And then from let's say 100 to 200, store all the data needed. All right, so they're going to fetch all the data and then store it here inside your main memory. That's why the idea of increasing the computer performance, one of it is by increasing the main memory size. Right, so as you increase the main memory size, so the more data that it can load at a time. So that's why if you have a limited memory, let's say you have a small memory, you cannot transfer all instruction at one time. So what happened? They're going to do the division, right? So they're going to pick all those important instructions first and fetch it here. So as you do your work, and then you are doing tasks that need some instruction that is not exist in the main memory yet, then it has to go and fetch it from the hard drive. Right? Then it's gonna take a while again, right? So that's the idea. So that's why if you're playing games, right? Let's say computer games. So whatever games, what's the famous game nowadays? Dota, is it? Is it Dota the streamline right now, guys?
Yes.
Okay, all right, that's good. Okay, so let's say Dota, right? For an example, so if you want to play Dota, let's say it is when you want to install it, there's a requirement, right? So you have to check the requirement whether your laptop or your PC met the requirement or not. All right, then a graphic is different thing, right? So that's why if you want to have a good graphic, then they implement graphic card, right? So this is additional, right? So this is your graphic card. So graphic card is going to do all the processing regarding the graphics. So that's why if you have a graphic card, then it's going to help accelerate your graphic view. If you don't have graphic card, then you just have graphic view. But you have a good graphic card, then you can view a very good quality image or video. Plus, you need to have a good monitor to that support the resolution. Alright, so let's go back here. So let's go back to the PowerPoint, right? So you have two things that they put inside the main memory. So as you have a bigger size of main memory, it's going to increase, right? The processing or the performance. But you cannot just simply, adding up the main memory. So that's why each laptop, each PC, there are limitation. So for an example, you want to upgrade your laptop RAM, right? You have to check first. One slot of RAM, what's the biggest size that it can support, right? For example, my laptop is quite old laptop. They have two slots, right? So they already told me, like the maximum for one slot is 4 GB. Right, so if I want to add another one, it's also maximum 4. So maximum I can have on my laptop is just 8 GB, which is not that good, but is acceptable, right? But if you have 16 GB, you have 32 GB, then it's going to be better in terms of performance. But why there's a limitation? Because when they design, right, so the motherboard, right, so all the things that they have in the processor, the main memory is located on your motherboard. So this is the motherboard. So all this motherboard, so you have this slot for RAM, right? So you have slot for RAM, then you have the PCIe Express, right? For your graphic card. So let's say this is your memory, right? So this is your memory. So they have fixed connection, right? So they have fixed connection and they can support what are the maximum address that they can support in the memory, right? So the limitation of the connection that limits, the number of the size of main memory that you can have on a PC. All right, so what we are going to emulate in this lab is this part here. So we have instruction memory and we have a data memory. And from there, we're going to fetch the instruction, then we're going to change all the control, to execute. All right, so if you guys compile all the thing, then you're gonna have this. Of course, this is the RTL view. All right, so this is the top level RTL view. So what you have here, there are two main block, which is control unit and data pass. Right, this can also be viewed on your quarters. Right, so you can see in the hierarchy. So all right, so the RISC processor is your top level module. Right, so this is your top level module. Inside the module, you have two big module, data pass and also control unit. And then you can see the drop down button here, and then you can see more modules that being connected within the data pass block. Right, then you can check it here. Right, so that's why if you double click data pass, then you can see there are other modules that be connected. So normally the modules will be put in green color. Right, so you have data memory, instruction memory, ALU control, and also the register, and the final one is your ALU. All right, then I've already do some modification to extract all the important lines or signals that we want to view, to make sure or to check whether our ALU, our RISC processor is working as the one that we have designed or intended, right? Okay, so it's all started from here, the instruction memory. All right, so you can see the instruction memory. So what's located, what's stored inside it. So the first one is the load R0 instruction. Okay, how do you know all these instruction? You go back here and check here. All right, so this is our instruction format. Right, so we have 4 bits for the opcode, we have 3 bits for the source register, and we have 3 bits for the destination register, and the last 6 bits is the offset, right? So offset means that where we want to go. Right? So let's say we set the value of the destination 0, and we want to move 2 location further. So that's the offset. All right, so you can see the opcode, right? So this is the opcode. If it's 000, that means load. 001, this is store. Okay, guys. This is exactly how the computer function. All right, so when you do the coding, right? So of course you don't do coding in this form. Right, so let's say you use C, you use Python, whatsoever, right? But after you compile, it's going to be break down into this small chunk of instructions. Right, so this is what the computer understand. Right, they don't understand the Python, they don't understand the C language, right? But what they understand is the instruction sets. So that's the compiler task, right? Okay, let's say you are writing a program in Python, right? Python, then you compile, right? So you compile it. So you do the compilation, compile. And by the way, I've changed to bigger mouse again. So as I see my handwriting improved a lot. Right. So when you compile, then you are changing it into machine code, right? The machine code. So machine code is in terms of instruction set. Instruction set, which is 0 and 1. So this is that will be understood by the computer, right? This one is for the human, right? To make the process for human writing a program easier. So that's why you can design your own programming language as long as it is easy to use, right? So that the complex part is on the compilation part. Right, so that's why during the compilation you get syntax error, because they really need to understand what you mean, right, in the programming. Then they're going to change it into the machine code. Right, so let's go back here. So, all right. So, and then this is the control signals. Right, so what are the control signals? The control signals are the one that going to control the whole, operation. So it's depend on what are the operation that you want to execute. Let's say you want to add, you want to load, right? So based on that, they're going to decide all the signals that they need to activate in the processor. Right, so let's go and look into the result of the simulation. All right, so okay, this is my simulation result. All right, so okay, what I'm viewing here. So you just see here, we just have a clock. Right, so same in your processor in your computer. So you just need a clock and you need a program. So normally you guys don't write except for C programming, right? The one that you learn, or whatever programming language that you are developing. Let's say C, yeah, you want to create a program. Let's say you want to create a, let's say, washing machine system or whatsoever. So you're writing it, then you compile it, then it's going to be loaded in the data memory and also instruction memory. Right, so what we are looking here is the output, right? So this is your clock, and then this is what happening inside or within the processor. Okay, so we can see the instruction sets during the first clock cycle is going to fetch the first instructions. Right, so okay, what is the first instruction? So the first instruction is load R0. Right, so this is first instruction is going to go and load R0 value. Right, so the R0 value is here. Right, so this is the R0 value, and then you can see here, right, the value is 1. And then goes to the second instruction. So second instruction is load memory R2 plus 1 to R1. So what happened is that it's going to go and fetch the second one and store it in R1 register, right? So this is the value. And then go to the third instruction. So the third instruction is asking you to add, right? So add register 2, register 0 and register 1. So you can and store it in register 2, right? So you can see the third instruction is asking to do the add operation. then that's why the ALU output, so the add operation will be happening at the ALU, then you can see the result, right? So 0, 1 plus 0, 1, 0 plus 0, 1, you're gonna get add, and you're gonna get 1, 1 as the output. Right, so what I want you guys to do in this lab, try to understand it. If you guys have any problem, you can ask me, but you have to understand in and out, right? So that's why I mean, like, there are a few things that you have to look into. The first one, of course, the coding itself. So what does it mean by ALU control, ALU? We have already covered most of the stuff, right? So we just don't have the data memory instruction. And then, so these are all the connections that we are doing. For example, you can see data pass, right? So, So all the connection happening here, right? So you can see here, this is the way we do the connection between each module, right? And then the other thing that I want you to understand is this part, the RTL part. So this is where you can go and check, how does we try to make sense, how does the code functioning, right? So it started from, okay, I'm telling you, it started from here, right? So that's why you see the PC increment, right? The program counter increment one by one to go and fetch each instruction, and then the instruction going to be transferred into the opcode and also the data, because these are all the informations that we have inside the instruction itself. Right, and then the final one is what are the main important output that you guys have to show, right? To show at the waveform simulation to understand or to prove that your code is working fine. All right. So is it okay, guys, or just confuse you guys? All right. So let's open for Q&A. Right. Any question, guys? Or if you don't understand, just let me know. I can try to explain which part that you don't understand. Hello, guys. Am I talking alone or what? Oh, okay. All right, so you guys still there? Or you guys already went to sleep?
No question, no question.
Okay, no question. What about others? Okay, need time to digest. Okay, all right. Okay, guys. So I think, okay, what you guys can do, okay, try to create this project and then try to work on it. Okay, I'll be here until 10. If you guys have any question, let me know. All right. Okay, go ahead, give a try.